feedbacks, comments, likes, and also being subscribed to my channel. If you are not subscribed yet, go ahead and do and subscribe now, and also click this bell icon so you will get notified. So how you are doing and how things going? I hope every one of you okay. So we discuss multiple topics in this channel, and some topic we kept on hold and some topics is keep going. But no matter what we discuss, there's a huge demand for one topic. When I meet people in the tech talks and the trainings and some other stuff, they keep asking one question: why you don't discuss this particular topic in your channel? This topic is pretty old. The topic by name is a threads in Java, but this topic is pretty old. But looks like a lot of people has a confusion and also a kind of a misunderstanding about these threads. So as a person who do a lot of interviews, and I also see when I ask some question from the threads, people go like, hey, why about this, their concepts, and like one explanation is contradict with others because they don't have a proper understanding about this concurrency and about the threads. So I decided to have a series of videos. So if you don't know anything about the threads, you are welcome. If you know a little bit about the threads, you are also welcome, because we are going to discuss from a very beginning to some advanced concept about the threads like inter-thread communication, and so little more advanced topic about the threads. So let's begin the journey. Why most of the times people have a misunderstanding about the threads? Because they always think thread is there just to cut down the time. For example, you know the project managers, right? So they always think, they always have this mindset. So they think if the one woman take 10 months to deliver baby, if we use 10 women, we can deliver baby in a 1 month. It's just a slang. Don't go mad at me and the project manager saying I insult you, because that is not how it's going to work. You use 10 women, you can't take the process up to 1 month. So likewise, if you have some process which run for 10 minutes, right? So there is no guarantee you can use a 10 threads to get cut down up to 1 minute. That is not how it's going to work. So let's take a small example and see why it is not like that. Let's say we have a process which has 5 steps. Let's say validate data, right? So validate take 1 second, and preparation take 2 seconds. I understand there can't be a processes like that, but just to understand, right? So currency rate, right, it take 5 seconds, right? So update model, it take 2 seconds, and a save to the database, it take 1 second, right? So altogether we have 11 seconds of processes, right? But looking at this chart, you will see you have a five steps. Can we use a 5 different threads and take this down to 11 divide by 5 up to 2 seconds? No, which is not possible. Why? Because there are dependency tasks. So what it mean by the dependencies are? For example, so you can't save the data before validating in the preparation, right? So there is no point you have a thread to save the data, because it is depend on validation and the preparation. So you can't do that. But what you can do is you can do this task and this task parallelly, right? So then you can use 2 different threads, but you can cut down the time little bit more than the 11 seconds, right? So maybe 8 seconds, maybe 7 seconds. That's only what you can do, because all others are dependent tasks. So I hope now you have a clear understanding how this works, right? So there is no way, 99.9% time, there is no way you can increase the number of threads and cut down the process up to 1 second or 2 seconds. That is not multi-threading. So then it is what? So multi-threading means multiple processes, multitasking, right? That is what it means to be, right? It means to be multitasking. So multitasking, if you take multitask, it has a 2 type of multitask, right? So one is process based, right? So other one is thread based, right? One is a process based, one is a thread based. What is the difference between these two? or what are the differences between these two? Here's like this. So sometime when you type code, when you type a document, you listen to music, right? So meantime, you may be downloading a movie or some other thing from internet. So that means you are doing multiple things on the same time. In the same given time, there are 3 processes running on your computer. So if you stop downloading a file, will it affect your music? No. Will it affect what you type? No. If you stop music, will it affect your download? No. Will it affect your whatever you type? No. So that means these tasks are independent. You can kill any task at any given time which does not give any single effect to others. So that means your operating system run multiple processes on the same time, which are multiple programs. So that is called process based multitasking. So then what is a thread based multitasking? The main significant difference is in a thread based multitasking, these threads are belongs to and supposed to belongs to same project or same main process which run in operating system. In the previous example, operating system has 3 different processes, right? As far as operating system concerns, there are 3 processes. In a thread based multitasking, as far as operating system concerns, it can be a one process, right? So within that one process, we divide this into multiple tasks. For example, let's say you have 50 files to process on your project, right? So what you can, let's say what your task is, read the file and save into the database, right? So if you think database is support for multiple threads and multiple save in the same time, if you forget about that part, let's say something like this. If you have a 50 files, let's say it take 50 minutes to work. You can use 2 threads and cut down the time probably for 30 minutes, right? So likewise, you can increase 3 threads. So what it does is one thread will go and take a file and process it and put it to the database. Same time, other thread will go and take other file and process into the database. Why? Because this task does not have any dependency, right? So you may use 50 threads and cut down the process up to maybe 5 to 10 minutes, but there is no way you can use 100 threads and take this time down to 1 second or something like that. There is no way you can do something with no time by just increasing the threads, right? So why you can't use more than 50 threads? Because you have 50 files, right? So there is no point 2 threads go and take the same file and trying to process it, right? So don't go extreme deep about this example, but I just use that example just to give an idea how the threads and what are the limitations of the threads, right? So now we know it, right? So as a conclusion, right? So there are 2 type of threads, right? So 2 type of multitasking. One is a process based, other one is a thread based. If it is a process based, those are independent from each other, right? You can kill any process at any time. There is no effect on others. But when you go to the thread based, those threads are belongs to one process itself, right? So if you take in the other way, right? So thread is what? Thread is flow of execution, right? Thread is a flow of execution. So if you take a one thread, right, it's keep executing all the things, right? So maybe multiple instructions you execute at the same time. But if it is a multi-threads, so from certain points it go to multiple flow of execution, maybe T2, T3, T4, like this, right? So there is a possibility at one point all those threads can come join here and keep going as a one thread from there onwards, which we are going to discuss, right? So so the point is the multiple threads mean multiple flows of execution, right? I hope now it's clear to you. So now how we can create a thread? How we can create thread in a Java, right? So there are 2 ways you can create threads, right? So one, you can extend, right? You can extend thread class, right? That's the one way of creating a threads. The second way of creating a threads, you can implement, right, runnable interface, right. So, no matter how you create, the behavior of the thread and what the thread does is won't change, but this give a advantage and disadvantage one way or the other, how it work. Let us take some simple example like this. So, we have a human, right, and we have a man. From a man we have a sportsman, from a sportsman we have a runner, right. So, this means this tells us this is an inheritance, simple inheritance, right. What it tells, runner is a sportsman is a man is a human. End of the day, runner is a human, right. In other words, we create man from a human because man is a more specific than the human. We create sportsman from a man because sportsman is a more specific than the man, right. We create runner from the sportsman because runner is a more specific. Now, for your reason, if you want to convert this to a runner into a threads, if you extend this from a thread class, right. So, what happens is it break this relationship. That means runner is a sportsman relationship, you break it, right. So, that means from here onward runner is a thread, right. So, in a previous inheritance, so end of the day runner is a human, which is a perfect valid scenario to present, but the moment you extend the runner from the thread class, you break that relationship. So, that is a one disadvantage what you are doing here. And the moment, because Java does not support multiple inheritance, right. So, so far at least. So, with the moment you create you decide to create a thread from the extended thread class, so you kill that relationship. So, that is bad. But Java support multiple implementation. So, it is always welcome to implement from the runnable interface, and also if you want to give a different behavior, implement from those interfaces as well. So, there is nothing called one way is better than the other way, as long as you know how it works and the repercussions of those is always you can go the way you want. All right. So, now the next part, right. Let us assume we have a class print extend from thread, right. So, here we have to override run method, right. Let us say this print, right, 0 to 1000, right, this print 0 to 1000. So, this is my thread class, right. So, in a main method, right, in other class, right, just say in other class, inside the main method, right. So, what I do is I create an object from printer, this let us say this is a printer p equal new printer, right. So, p dot start, right. So, you can see you do not have a start method inside the printer class, but printer come from the thread class. So, thread has a start method. So, I will show this code in the next video, right. So, after this main thread also printing from 0 to 100, right. This will be a perfect valid interview question for you. So, now how this works. So, look at here, right. So, this point, right. So, this point we call we create instance from the thread, otherwise we call instantiation a new thread. So, here we start the newly created thread. So, from up to here, right, if you take the programming flow up to here you only have a one thread, but from here you create a second thread. Now, your program has a two threads, right. This is a child thread, but keep in mind we are going to discuss this in future, but the moment you say thread.start or p.start, that does not give you any guarantee that it will start instantly, right. It has to go through executor and so many other processes which we are yet to discuss, right. So, now from here you have a second thread. So, this is the one of confusion lot of people has. The moment it start the new thread, it is just a one instruction for the main thread, right. This is called main thread, and from there onwards is again it's keep executing the rest of the commands, right? So that means in our program it will come here, it will kickstart this new second thread and it will keep going and it will print to 1 to 100, right? So here's the tricky question. Now main thread start a new thread which is a child thread which is supposed to print from 0 to 1000, right? So and after the start the main thread will print 0 to 100, right? If you think fair basis, 0 to 100 will print faster than the 0 to 1000. So now my question is, now what is the behavior of your project? Will it stop, terminate the project just after printing 1 to 100? That means the child thread will not able to complete its job, because a lot of people think Java always terminate its program when the main thread exit, right? So theory is not that. Java terminate a program only two cases. One is if someone calls system.exit, what it does is, or when you terminate, when you kill the last non-daemon thread. So that is how the Java program exit. So in this case, we didn't mention the new thread is a daemon thread or non-daemon thread. It will have a default behavior. We don't know what is it yet. So now my question is, so now the moment it print the 0 to 100, maybe this time child thread is still printing somewhere around 200, right? So what the output will see? Will the program will terminate, or will the program will wait until the child thread complete its 0 to 100 and then exit, right? Okay, so that's a tricky question, but we will going to understand more than a tricky question than this in upcoming videos. So till then, I'm going to conclude this video. So we just got a very basic introduction to threads, and stay in touch. So subscribe to YouTube and just click on this small bell sign so you will get noticed whenever I release the video, and then like to my Instagram and the Facebook page. Stay in touch. We'll see you soon in the next video.